Welcome to the video notes for Module 14, Part 1. In this section, we are going to look at how to do a confidence interval for a proportion. So in Module 15, we looked at how to perform a hypothesis test. One of the important things about a hypothesis test is that you have to know some information about what the population proportion could be in order to set up your null and alternative hypotheses, meaning you have to have some sort of previous study that was done, or you have to be able to find census data or something like that so that you can use kind of as like a baseline for that null and alternative hypotheses. The reality, however, is that sometimes you may not be able to find what the population proportion is because the study that you're doing has never been done before. So when this occurs, we can create a confidence interval to estimate where the population proportion may fall. And the idea behind this is that we're going to be looking for the middle 90, 95, or 99% of the data. Just like we did back in Module 11 where I said, okay, find the middle 50% of the data, and we did all of the stuff to find that. It's the same idea that we're going to be following here, except for now we're using p hat instead of an individual data value. So the first thing we have to do is we have to find a point estimate for the population proportion. We are going to use the sample proportion as our point estimate. So basically we're going to say, all right, I don't know what the population proportion is, so I'm going to use my sample proportion as my best estimate. So let's review quickly how to calculate p hat. So the first example, the Gallup organization conducted a poll in which a simple random sample of 1,016 Americans 18 and older were asked, do you consider the amount of federal income tax you have to pay is fair? Of the 1,016 adult Americans surveyed, 558 said yes. Obtain a point estimate for the proportion of Americans that believe the amount of income tax they have to pay is fair. So our p hat equation up above, as you can see, is x over n. X is the number of individuals with the desired characteristic. So in this case, it's going to be the number of individuals that said yes. So our p hat is going to be 558 over n is the sample size, so 1016, because that's how many people we surveyed total. And when you do 558 over 1016, you get 0.5492. So that's just a quick review on how to find p hat. So now let's look at how to create that confidence interval. So the equation for a confidence interval is p hat plus and minus, meaning we're going to do this entire equation twice. First time we're going to add, second time we're going to subtract. A z alpha over 2, which we'll talk about in the example, times the standard deviation. Now notice this standard deviation equation is a little bit different than the standard deviation equation we've used in the past. That's because that standard deviation equation relied on knowing what p was. We don't know what p is, so we're using p hat as our best estimate. The only time you will use p hat in your standard deviation equation is when you are conducting a confidence interval. If you're doing a hypothesis test, if you're finding what the standard deviation would be, you would use p. If you have p, this is the assumption that we don't have p. All we have is p hat. So let's go ahead, we're going to get straight into an example of how to calculate this. So in the parent teen cell phone survey conducted by Princeton, 800 randomly selected 16 to 17-year-olds living in the U.S. were asked whether they have ever used their cell phone to text while driving. Of the 800 teenagers, 272 indicated that they text while driving. Obtain a 95% confidence interval for the proportion of 16 to 17-year-olds who text while driving. So just as before, we're going to start this problem by highlighting important information we've been given. So the first important piece is that they surveyed 800 people. 272 indicated that they have done what it is we're interested in. and we want to obtain a 95% confidence interval. That's all we really need in order to do this confidence interval. We need to know how many we surveyed, how many of those surveyed said they'd done the thing we asked them if they had done, and then what percent confidence interval are we looking for. So what we're doing, and this is not an official step, but if I were to draw my normal curve, this is under the assumption that this is normal. I want to find the middle 95%. So I want to know what's this possible p-value and what's this possible p-value if the middle p-value is my p-hat. So that is what we're trying to do with the confidence interval. So the first thing we really do need to do is we need to make sure that we have a normal distribution. So as you recall from before, we can find if a distribution is normal by taking n times p and verifying that it's greater than or equal to 10. We don't know what p is, so we're going to use p hat. So we need to first figure out what p hat is. P hat equals 272 over 800. And that is 0.34. So now, is 0.34 times 800 greater than or equal to 10? Well, it's equal to 272. So yes. How about 1 minus 0.34, as we also have to check that guy. Minus 0.34, and that gives us 528. So we're good there. We have a normal distribution using p hat as our best estimate for p. So now, using this idea that we're trying to find the middle 95%, I need to find this z alpha over 2. So coming back up to this equation up here, we found p hat, so we need to find z alpha over 2. And then we're just going to plug everything in. So step 2 is to find z alpha over 2. So alpha, in this case, is if I rewrite this 95% confidence interval as 1 minus alpha times 100%, how would I get 95%? Or another way you could look at this is alpha is whatever plus the given confidence level will give you 100%. Okay, so that means alpha has to be 5%, because 95% plus 5% equals 100%. So alpha as a decimal is 0.05. I am really running out of room here. Okay, and then we're going to find the z-score that corresponds to an alpha over 2. So I need to find alpha over 2, which is 0.025. So now I have an area. I need to go and find a z-score. I'm going to have to come down into this next example because I ran out of room really quickly. Or actually, I'll write it up here. So if I have a z-score, or if I have an area and I need to find the z-score that corresponds to that area, we go to inverse norm, which, if you recall, is in your second VARS list, and it should be the third option. You're going to type in 0.025, 0, and 1. Make sure you leave those as 0 and 1. Otherwise, you're going to get the wrong answer. Okay, so let me actually show 0.025, 0, 1. And we get negative 1.96. This negative 1.96, and that is rounded correctly, is the z-score that I'm going to use to find this possible value for p. This possible value for p will have a z-score of positive 1.96 because the bell curve is symmetric. So I'm going to ignore the negative because the negative comes in when we subtract in this equation up above. So now I'm going to use the pieces of information I just found. I'm going to plug them into this equation up here, and that's going to give me my confidence interval. And I'm going to use this space up here because I continue to run out of room. So the equation that we're going to use is p hat, which we found to be 0.34. Oh my goodness gracious. Whoops. 34 plus and minus our z alpha over 2 is 1.96 square root of 0.34 times 1 minus 0.34 over 800. Don't forget to take the square root of that, and don't round anything until you get to your final answer. So 0.34 minus, I'm going to do the minus side first. .34 times 1 minus 0.34. I apologize, I did not calculate this beforehand. Over 800. And I get 0.3072. And then if I repeat this process, but I do addition instead of subtraction, so I did the subtraction piece in this equation, this guy right here. Now I'm going to go back and I'm going to redo everything, but now I'm going to add instead of subtract. Plug in everything in. Plus, and we get 0.3728. All right. So what I've just found are the two possible values for these p's, and there's a 95, oops, I don't know what I did. Okay, there we go. There is a 95% chance that the actual population proportion of teenagers that text while driving is between these two numbers. Okay, so a couple of more pieces of information before we do the interpretation of this. This piece of the equation right here, this 1.96 times the standard deviation, this is called the margin of error. And it basically says, hey, I think that my p hat is wrong, and this is how wrong it is. This 1.96 is how the 95% confidence interval comes in, and then our estimate for the standard deviation. Okay, so I kind of had steps. I'll try and flesh the steps out a little bit better in this second example that we're going to do. But let's go ahead and look at how we would interpret what we just found. So it's an estimate for the population proportion. So we are 95% confident that the population proportion of teens text and drive is between 0.3072 and 0.3728. If you want to turn those proportions into percentages, that's fine with me. Okay, so we're saying that we are 95% confident, or there is a 95% probability that the actual proportion of teenagers that drive and text is between roughly 31% and 37%. I don't know exactly what it is. Okay, I don't know what that population proportion is, but I'm 95% confident that it's between those two numbers. And that's a confidence interval. Okay, so let's go ahead and look at another example of how to calculate a confidence interval. And I'll try and give you some better steps this time. So a 99% confidence interval for the texting while driving information from the previous example. Okay, so we're using the same information. So let's actually make step 1. Find p hat, which we have already done because it's using the same information. Okay, come on, pen. P hat we found was 0.34. Step 2 will be to verify that it's normal using p hat in place of p, which we also did in the previous example. So our n times p was 272, and our n times 1 minus p came out to be 528, both of which are bigger than 10, so it's normally distributed. Step 3 is to find z alpha over 2. So this is the tricky part. So you're going to go to inverse norm. Now this problem is asking you to do a 99% confidence interval. So the remaining percentage to get you to 100% is 1%. And then I want to divide that value by 2 because I'm looking for the middle 99%, which means 1% is left over. And on one side of my curve is half of 1%. So 0.005, 0, 1, which will give us, I'm not sure, 2 point something. I believe it's 2.575 something. How about I just calculate it instead of continuing to guess? I know it's 2 point something. Negative 2.5758. I was pretty darn close. Negative 2.5758. So that's the z alpha value below the mean, and then we have one above the mean, but because it's a middle 99%, we know that the other value will be the same, just positive. So we're just going to ignore the negative sign altogether and make it a positive sign. Step 4 is to plug everything in. So 0.34 plus and minus 2.5758 times the square root of 0.34 times 1 minus 0.34 divided by 800. This is going to give us our estimate for where the population proportion is between. And this is an interval that I'm even more confident in. So let's go ahead and plug all of this in. The nice thing is only one value is different from last time, so I don't have to change too much in the equation. Just have to get there. Okay, 2.5758. All right. So we've got 1, and then we do it again, and we get the other value, which, yes, I will tell you what these values are. One moment once I finish calculating. All right, here we go. So I get what's called my lower bound is 0.2969. That's a 0. And my upper bound is 0.3831. So those are the values that I believe the population proportion is in between. So my final step is to write an interpretation of this interval. And the idea is that I could give this interpretation to my grandmother and she would know what I'm trying to say. So now we are 99% confident that the population proportion of teens that text and drive is between 0.2969 and 0.3831. And that is it. Okay, so summary of confidence intervals. So we are creating a confidence interval because we don't have any information about the population proportion. There's no previous study that we can look at to kind of say, okay, are things different now from what they used to be? There is no what they used to be. So we recapped how to calculate p hat, and then we looked at the equation to calculating population proportion, which is p hat plus and minus a z-score times a standard deviation, and we're using p hat in place of p in the standard deviation equation. This second half, the z times the standard deviation, is also known as the margin of error. So then the steps to complete a hypothesis test: first, find p hat. Second, verify that you're working with a normal distribution. Third, find that z value by taking whatever the given percentage of confidence is, figure out what is remaining to get you to equal 100%, divide that by 2, and then plug it into inverse norm, and then take the p hat that you found and the z-score that you found and plug each of those values into the confidence interval equation. Get your answers once by doing the equation with a subtraction, again by doing it with addition, and then finally write out your interpretation. Now the nice thing is there will be a calculator video that shows you how to do the confidence interval piece in the calculator. So all you have to worry about is verify normality, find the two values, and write the interpretation. So it's kind of like step 2, and then steps 1, 3, and 4 are going to be done in your calculator, and then step 5 you have to do as well. So that's it for confidence intervals for proportions.